So you're here for the Mike Plus built-in functionalities for robust river system analysis webinar. This is a continuation of the webinar series we've started in spring, and I'm happy to welcome Mihai with me, who will be the presenter today. He has 10 years experience with DHI, specialized on river. That's good today. He's done flood mapping, urban flooding, and sediment transport. That's where he actually writes his PhD right now. My name is Thomas Telekti. I'm global product specialist for Mike Plus Pipeflow. So my aim is to develop a community of practice for Mike Plus. And with that, I'll hand over to Mihai.
Thank you, Thomas. Hello all. I'm very happy to have you all here to this Mike Plus webinar. So today we'll be talking about Mike Plus, and I will be providing some information, details about what Mike Plus is, what it represents, how could we use it in our day-to-day working life, and the types of applications, types of functionalities, tools, workflows that generally help us in developing models, very high quality models, and obtaining the needed results from them. This is an introductory webinar, so I will go through the main functionalities, let's say from scratch. So at the end of the webinar, you will be able to have a grasp, a general overview of the Mike Plus functionalities, tools, so everything that you would need in order to start working with our solution. So the agenda for today would go a little bit into the introduction to Mike software, because Mike Plus is not our only solution. So I'd like to just provide the general information on other software solutions that we have. I will go through the Mike Plus functionalities and main modules, and then describe what kinds of applications and functionalities we have available for different types of modeling approaches, albeit 1D, 2D, or coupled 1D, 2D applications. So first, let me start with a very short introduction to our Mike software and, let's say, DHI in itself. DHI has a history of more than 50 years in dealing with water issues. So a long time, there was a need for developing specific software. So DHI has also started developing, implementing its own specific hydraulic modeling software. So we are dealing with software or with water issues and developing software solutions for basically any type of water-related study. We are talking about integrated water resources management, where we have Mike Hydrobasin, Mike She, or Mike 21, urban networks, and we are talking here about Mike Plus and also West, which deals with wastewater treatment plants, and groundwater, and here we have FIFLOW. So you could say that we are dealing with all the water resources and cycle, going from mountain streams to lakes, rivers, reservoirs, groundwater, and also drinking water. If a specific project has, let's say, certain specifications or requirements, the software can also be tailored to these specific needs. This is where Mike Operations comes into play. It contains built-in functionalities and tools for development and tailoring in fields such as flood warning, decision support systems, water quality forecasts, real-time inflow forecasting. So we can gain access to different tools and applications that can help us in these domains. Also, DHI offers access to different applications and platforms that offer various types of data, for example, bathymetry or bird monitoring, for example, or other types of online platforms that can allow beneficiaries and stakeholders to have access of their systems in an online application and make decisions based on their own platforms. Anyways, more information about this can be found on our sites, dhigroup.com or micpoweredbydhigroup.com. Going further to our presentation, I will be talking about the Mic Plus modules and how we can use it for different types of application in urban, rivers, and flooding applications. So Mic Plus at its core represents an integrated platform, and it provides built-in functionalities for a range of domains related to water. I have detailed on this slide the four main components that Mic Plus has. The first one being the urban water networks. So Mic Plus can help in developing water distribution and water collection systems models, and can help in fully assess the hydraulics of these urban water networks. Secondly, it can be used to model rainfall runoff processes for both stormwater and rainwater collection systems in the urban areas, but it can also be used for the river systems hydrology. It also contains elements for complex river flows analysis, which can take into account also water quality and sedimentation processes. And last but not least, it contains instruments for assessing flooding processes, both on small scale models, for example, urban areas, but also for larger scale, even let's say catchment scale flood models. All these components are part of one singular integrated platform, which can be customized to the needs of each users and to the needs of each project by just selecting the necessary modules, the necessary parameters that are needed for a specific application. So it unleashes basically a full array of features that delivers the specific type of project you are working on. Because Mic Plus is an integrated platform, it means that it contains multiple modules. So all these modules have to be managed by an application, which in our case, it's called the model manager. This model manager allows easy access to data, to tools like import and processing of data, both pre-processing as well as post-processing, and result presentation. The model manager ensures interaction between various types of processes. So for example, if we are modeling a coupled 1D, 2D application, the model manager ensures that the two models communicate and all the relevant parameters are being transferred from one system to the other seamlessly and without user intervention. Apart from the model manager, Mic Plus also benefits of ArcGIS Pro capabilities by allowing the modeling database to be accessible in ArcGIS Pro. In ArcGIS Pro, we can use a range of GIS tools that can be used to take the most out of the data and out of the model, and we can use it to perform various analyses under a GIS environment, which provides very powerful tools for data processing and result interpretation. For the next part of the presentation, I will go through I will make an introduction to the capabilities available for the 1D modeling component in Mic Plus, and I will provide examples of the types of applications that are suitable for this approach. For river systems modeling in the 1D component, we can look at the functionalities that Mic Plus offers in terms of river hydraulic analysis, reservoir operation and control, and also water quality and sediment transport processes. These three types of applications would cover a broader range of specific studies, but these studies would have to have these basic concepts as a base. So in the next slides, I will go through the range of tools, workflows, all the functionalities that we have available for these types of applications, just to give you a general overview of what we can do using the 1D component in Mic Plus. So when it comes to river modeling in Mic Plus, it can help by offering the possibility to represent both simple channel flows as well as complex channel flows. So we can model simple channel flows such as singular rivers, which have a well-defined flow path with little to no floodplain. But also we can represent complex interactions between channel flows and floodplains through the use of parallel branches. I have also attached here an example. You can see the picture on the left side of the slide, which shows an area where floodplains needed to be implemented as part of the 1D model in order to define also the flow in the floodplain as accurately as possible. So by using the parallel branches in Mike Plus, we can represent secondary flow paths that can become active under certain conditions. For example, the water level is higher than the crest elevation of a dike, then water is allowed to flow from the main river channel to the secondary flow paths. Mike Plus, under its 1D modeling module, can model also complex structures such as bridges, weirs, culverts, retention basins or polders, gates and spillways, or any other structures that can be assimilated to these ones that I just mentioned. And it offers various parameters that can basically be tweaked in order to obtain a representation as close as possible to the real situation. Regarding the types of flow conditions, Mike Plus can take into account and model steady or unsteady flow conditions, and also can consider different types of boundary conditions, such as discharges, water levels for tidal applications, local inflows, or distributed inflows. Also, depending on the studies, specifics can take into account rainfall runoff processes through various complex hydrological models that I will detail in the upcoming slides. As I briefly mentioned on the previous slide, Mike Plus allows for the representation of complex structures such as gates and spillways when we are talking about studies that involve reservoirs, and also offers the possibility to control them based on different sets of control rules that can be easily defined by the user. These control rules consists of, let's say, basically pairs of sensors that trigger when a control rule is going to be activated. For example, here we could talk about the water level reaching a specific level inside the reservoir, and an action which controls what happens when a specific trigger has been activated. So we can think about a scenario where the water level reaches a certain threshold, then the spillway or the gate could be opened by 50 centimeters. So this is one example of the kind of a control rule we can define in Mike Plus. Mike Plus offers a large variety of control rules and actions which allow for different types of studies to be carried out. And by different studies to be carried out, we could think of reservoir optimization, for example, for both flood protection purposes or for drought management scenarios. So depending on the project specifications, users can also look into these optimization procedures as well as other optimization procedures such as maintaining the water level and managing the release downstream in order to optimize for hydropower generation, or even from the ecological side, analyzing and assessing the discharge release downstream in order to maintain a healthy water level in the reservoir, but also the minimum ecological discharge downstream of the reservoir, so that we can maintain a healthy ecosystem both in the reservoir and downstream of the reservoir. Mike Plus can also be used for emergency action planning. So for example, in case of a reservoir management and action planning for dike breaches, it offers full functionality for simulating dam break wave propagation under different conditions. So using Mike Plus, we can use the dam break module that provides various types of dam break types like overtopping or piping. And also under these main typologies, we can use different triggers or equation sets that allow the user to tailor for specific needs. For example, we can use the dam break module to trigger a dam break when the water level in the reservoir has reached a specific level defined by the user, or to breach at a specific time also defined by the user. By using the dam break functionalities and the full hydrodynamic model, we can propagate the dam break wave downstream and look at various parameters, such as the time needed for the flood wave to reach certain locations, as well as discharges, water levels, velocities calculated in various cross sections along the river. All these parameters are extremely important for an emergency action plan and also for a risk analysis, by looking at potential population being affected and also various ways to protect population and locations where they could be evacuated. On the slide, I have also attached a video where you can see a simulation of a real dam break analysis. We can see the longitudinal profile and also the discharge caused by the dam break itself. Apart from the hydrodynamic capabilities, Mike Plus also offers a full range of tools and functionalities to simulate various water quality processes. Mike Plus integrates the advection dispersion module that can simulate the propagation and also decay of different substances in the river system. But apart from the advection dispersion module, it also integrates the ecological lab, as we call it, EcoLab software, that can help simulate ecological processes. It contains tools and various templates to calculate complex water quality components and processes such as bacteria growth, heavy metals, sediment interaction with water quality, and can be used for shallow or deep water ecosystems. The advection dispersion capabilities and also the integration with Ecolab allow for very complex processes to be represented and modeled using Mike Plus. Sediment transport is also one of the main processes happening in any river system, be it river or reservoirs. And in this regard, Mike Plus offers full functionality for 1D sediment transport. It provides tools and functionalities for both cohesive and non-cohesive sediments. It allows for specification of multiple layers and fractions. So it provides basically the possibility to model the area and the domain as close as possible to the real representation in the field. And it offers multiple formulations, both for the cohesive and non-cohesive sediment transport, that can calculate and provide results regarding bed loads and suspended loads, offering a very high detailed overview on the entire sediment transport process. What Mike Plus also does is take into account the morphological update process. So during the simulation, it automatically updates the relevant parameters, for example, the effective flow area that can be affected by the ongoing processes of erosion and deposition caused by the sediment transport process. Mike Plus can also be used for applications where rainfall runoff processes represent an important component. And we are talking here about pluvial or fluvial flooding. It can model a various range of applications from urban rainfall runoff processes where we have to take into account highly impervious areas, such as buildings, roads, or other paved areas. And also it can model large-scale hydrological analysis where historical data is available and can be used both as input data as well as for calibration purposes. For these purposes, Mike Plus offers a range of hydrological models which can simulate both single events and also extended period events. The single events can be modeled by different types of hydrological models, and I have listed on this slide the time area method, kinematic wave, linear reservoir, and the unit hydrograph method. Some of them take into account only the rainfall runoff, some of them take into account also infiltration processes. But for the extended periods events, we have a hydrological model called rainfall dependent infiltration, which has the main advantage of possessing, let's say, a hydrological memory and takes into account infiltration and base flows from previous rain events. This model can also consider other adjacent processes that can happen in a rainfall runoff process, such as snowmelt, groundwater abstraction. So by integrating all these tools, Mike Plus can help better understand and calibrate the hydrological models. Depending on each project size, data processing and handling can become quite time heavy. So this is why Mike Plus also includes a series of built-in functionalities and various tools that help the users save valuable time. So we can mention among these tools the ones that I have put on the left side of the slide. Instruments such as delineating rivers or cross sections based on a digital elevation model. This can be done automatically by taking into account parameters provided by the users, such as distance between consecutive cross sections or cross section length. We can create cross sections based on surveyed XYZ data. So if we have this already available, it's only a matter of import, which saves significant amounts of time than just manually entering cross sections into the model. We have possibility for editing multiple cross sections at a time. So parameters such as effective flow areas by defining river banks and flood markers, and also roughness coefficients assignment can be done automatically, and also saving time in the model construction phase. Other tools that are extremely useful are, for example, assigning the resistance based on external files. So based on shape files containing the land use type and roughness coefficients, they can be set into the model using an automated manner. And last but not least, computing storages like reservoirs and polders based on the DTM. And in this case, we can extract elevation area or elevation volume curves based on the data loaded in Mike Plus as elevation data. All these tools in the end serve the purpose of making the model building process easier, faster, so the time saved can be used, for example, for result interpretation or other activities in the modeling process. The result interpretation process is basically one of the key components in hydraulic modeling. So this is why Mike Plus offers various types of results, which can be viewed under different types of formats. So Mike Plus offers the possibility to have results displayed as visual maps or different types of graphs, as we have on the slide, the water level or discharge hydrograph, or the cross-section plot, which shows the maximum water level calculated for this specific scenario, and also provides the possibility to view the results as tabular format or in a report format. For example, creating a difference between two results and viewing the report regarding the differences between those simulations. Other types of results that can be viewed are the longitudinal profiles, showing different items such as river banks, talveg, maximum, minimum, or dynamic water level. One of the ease of life functionalities that is implemented in Mike Plus is, for example, the possibility of exporting the longitudinal profile in CAD, which can be used to create plots and maps showing various elements such as river banks, dike elevations, water levels. This is a very important functionality and has been requested by many clients, at least from our experience, because it's very easy for them and also for designers to view the necessary informations in a CAD format, and then it helps us understand their system and design those measures to tackle specific issues which were identified through hydraulic modeling. In the next part of the presentation, I will cover the main functionalities specific to 2D modeling, and I will talk about the types of applications and tools available in Mike Plus for 2D modeling of river systems. The types of applications which are available for 2D modeling are basically the same as for 1D modeling, considering that Mike Plus is an integrated platform, so the processes that can be done in 1D could also be done in a 2D approach. The main advantage of Mike Plus in this regard is that under the same interface, we can deal with 1D applications. And in case we need further detailing in specific areas, then we could switch to a full 2D approach. And in this way, we could gain a lot of benefit from using 2D meshes, both for hydrodynamic calculations as well as for water quality processes in rivers and in reservoirs. Using Mike Plus, you have a choice between different types of domain discretization. Mike Plus offers a full rectangular mesh as one discretization method, and a full flexible mesh approach. Out of these two options, and the one that is also presented in the pictures on the slide, is the flexible mesh approach, which is very versatile. It offers the possibility to tailor the domain and the calculation elements depending on the type of project and also the degree of detail that you would need. The flexible mesh can use triangular elements, it can use rectangular elements, or a combination of the two, depending on the user's preference on how they would want to treat the system. So among the main advantages of the flexible mesh approach is that it can accommodate for different types of elements like flow obstructions in the area. These are called, let's say, longitudinal elements and can be described as roads, dikes, embankments, railways. So any type of element that can be described using a long rectangular calculation cell. So the flexible mesh allows for full flexibility, as the name suggests, and also it allows for different element sizes to be defined by the user, depending on their need for accuracy and discretization in different areas of the domain. The two images that I presented on this slide are from a real project where the purpose was to identify the flood-prone areas and check the inundated areas caused by different synthetic flow hydrographs. And we chose to represent the channel as a full rectangular mesh. The floodplain would be considered using a full triangular mesh, and then the elements like dikes, roads could be considered depending on the user's preference, either by using a rectangular element mesh or a triangular element mesh. But the idea is that we can create much more refined areas where we need to have a better representation in order to also compute with high precision and no instabilities all the flow parameters. Similar to the 1D models, Mike Plus offers also a range of functionalities that allow for various types of processes to be considered in the hydraulic modeling activity. One of these functionalities is the possibility of including buildings and roads into the computational domain. And we have a couple of ways on doing this. One of the methods is to raise the buildings on their footprints in the 2D domain. And this can be used to represent, for example, the finished floor of different houses, blocks of buildings, or other types of buildings. We can also use this tool to burn in the roads in order to take into account for the difference between the sidewalk elevation and the road elevation, so basically accounting for the curb. These kinds of functionalities are very useful for flooding studies, especially for small-scale urban studies, because they help simulating the flood event much closer to the real behavior, and also they are leading to a more realistic assessment for both the flood hazard assessment, but also for the flood risk computation. The flood risk component also is an important one because, for example, if using damage curves which start from the finished floor level, then it would be important that the modeling activity also reflects that. Again, falling into the ease of life functionalities, Mike Plus embeds a series of possibilities to consider the roughness coefficient specification, which is one of the main parameters to be adjusted when calibrated the hydraulic models. The users have the possibility of specifying the roughness coefficients based on external land use shapefiles that can be loaded as a background file into Mike Plus. And then it offers a series of functionalities and methods in which the roughness coefficient can be specified. The first one is that the roughness coefficient would be considered varying in domain. This would be represented by a static map where the roughness coefficient is taken from, for example, from the land use type shapefile. Then the second option would be varying in time and domain. And this would mean that Mike Plus can account for different land use changes, for example, deforestation, or maybe changing a rural area to a more urban area, or construction of a large industrial area. So these kinds of landscape changes can be taken into account by varying the roughness coefficient in time. And the third option would be to consider the roughness coefficient varying in domain, but also dependent on the flow. So we can consider the roughness variable in the domain, but also variable in relation to the water depth or the discharge flowing through an area. For certain applications where there is a need for high degree of detail, but maybe the degree of detail for the input data is lacking, Mike Plus offers additional methods to improve on the data and also to improve the overall quality of the model. Mike Plus offers the dikes functionality, where the user can take external data, such as dike crest level surveys, which would be consisting of XYZ information, and apply them on a mesh in order to overwrite the DEM data in the model. This functionality is especially useful in applications where we have to deal with narrow structures, such as retaining walls located on the river banks, especially in urban areas where they are usually narrow retaining walls, which sometimes can be misrepresented by the DEM. Through this dike functionality, the user is ensuring that the model actually takes into account the real crest elevation, and then the flooding process occurs only if the discharge and the corresponding water level is high enough to overtop the real crest elevation instead of the one that would be captured by the DEM. Similar to the 1D module, the 2D module provides functionalities for varying the dikes or dams crest levels in time. So it allows for simulating a dike or a dam break. This functionality is very useful for emergency action plans. It's similar to what we have discussed for the 1D modeling approach, but it has the added benefit that the flow parameters are now distributed on a flexible mesh, and the degree of detail available is much richer than for the 1D approach. In the images attached, you can see an example from a study we have done in Romania, where we have the initial flood extent portrayed by the more intense blue in the foreground, and the flood extent obtained after creating a dike breach scenario with the faded blue in the background. Also, you can see on the right side the discharge that goes through the dike bridge that has been created in the 2D model. Also, I would like to present a study that was the results of a study that was done by our colleagues in DHI Slovakia regarding the Kakovka dam break in Ukraine that happened a couple of months ago. This simulation shows the propagation of the flood wave caused by the dam break and can offer significant and valuable information about the timings and how long does it take for the flood wave to reach certain locations, what are the velocities in the area, water depths, and so on. These results were very interesting and also were handed over to the Office of State Service for Emergency Situations in Ukraine. And as far as I know, they have also been made part of the official UNEP report on rapid environmental assessment of the Kakovka dam destruction. Mike Plus also offers functionalities for reducing the computation time, because we all know that time is a critical parameter when it comes to the hydraulic modeling, especially when it comes to large models with high degree of detail. So Mike Plus offers possibility to parallelize and use GPU cards to speed up the simulation process. Models can be run using either CPUs or GPUs, and the user has the possibility to choose how many threads and cores can redirect towards the computation of the model. Multiple GPU is also available in Mike Plus. So if you have a unit with several high computational cards, then you can successfully use it to run large models with several hundreds of thousands or even millions of elements that can really help deliver the large model results in due time. In terms of results, we already saw some types of results from the previous slides. In general, the 2D modeling capabilities include options for creating dynamic maps and also static maps. The dynamic maps can show the main flow parameters like the water level, water depth, and flow velocity. But we can also obtain static maps, for example, arrival time of the flood wave, inundation time, water depth or velocity above a specific threshold, which can all be very useful in assessing the flood hazard and also in assessing the flood risk. These results can also be visualized as maps. They can be exported and visualized as time-varying longitudinal profiles and even point time series. And as you can see also from the image on the left upper side, we can also assess the 2D culverts and weirs results, as well as cross-section discharges anywhere in the 2D domain. All these results can be extremely useful and can be used to fully understand the processes in the area and to make informed decisions based on high quality results. For the last section of the presentation, I will talk about the main functionalities for coupled 1D 2D applications. So as 1D and 2D modeling components are part of the Mike Plus integrated platform, they represent very strong approaches. And Mike Plus offers also the possibility of coupling them, bringing basically the best from both worlds. So we can simulate with high precision what happens if the water reaches the floodplain or an urban area, while also simulating with high precision the water level variation inside the structure or in a reservoir under different types of control rules. Coupled modeling is really much easier to perform in Mike Plus rather than it was before, considering that it is a single platform and it contains all the tools, all the modules needed to carry out this type of analysis. Just as a couple of details regarding how Mike Plus works in regards of the coupled 1D 2D approach, Mike Plus offers the functionality of two types of linkages. On the left side of the slide, we can see the lateral link possibility where we can couple a river system with a 2D domain along the river, and then water can be transferred from the 1D system into the 2D domain and vice versa. And on the right side, we can see the second type of approach where we have a river system on its own, and then it spills water into the 2D domain using a standard link structure. The standard link structure also can transfer water from the 1D to the 2D domain and also vice versa. So the links help simulate the water transfer between the systems. They are fully dynamic, so water transfer is being done automatically, and also they are bidirectional, allowing the water to transfer from the river to the floodplain, and then again from the floodplain to the channel when the water level in the channel has receded. Among the, let's say, ease of life tools that Mike Plus offers, it also allows the automatic identification for lateral and for standard links and automatic delineation. The lateral links can be used after they are delineated automatically to exclude the river channel area from the 2D domain in order to avoid a process called double conveyance, where the volume which comes out of the 1D system can flow back into the 2D domain, which is something that we would like to avoid. So based on the tools that Mike Plus offers, we can exclude the river system from the 2D domain. So the 1D system can calculate the water levels inside the cross sections, after which the water is being transferred to the 2D domain, and we calculate all the relevant parameters using different sets of equations. Mike Plus allows for automatic coupling of the 1D models, and it allows it both for the lateral and for the standard links by the functionalities that are shown right now on the slide. So we can do it for the natural channels and riverbanks, and we can do it automatically for the river ends. As mentioned in the beginning of this part of the presentation, the main advantage of using 1D, 2D models is that we can very accurately represent all the important details in the river system without having to greatly simplifying one component or the other. So this is an added benefit of this kind of analysis that can be done in Mike Plus. Furthermore, a coupled model could also lead to less computation power needed, but this is also highly dependent on the model type, on discretization, mesh size, and so on. Just as an example of some applications where the 1D, 2D approach could be suitable would be situations where we have structures and floodplains that would need to be modeled using high precision and detail for both components. So a situation like a dike or dam break model can be the case here, where complex control rules can be simulated in the 1D component, and the flow propagation can be dealt with in the 2D component. Another type of application could be urban flooding applications, where the river channel and the flow protection infrastructure could be defined by the 1D model along the river, and the urban area can be defined using the 2D domain and the mesh available in the model representation. In terms of result presentation, we basically encounter the same types of results as for the separate components, because we are in the end modeling a 1D and 2D components, but let's say linked together. So the added benefit of Mike Plus is that it's combining also the results, and we are able to extract discharges. We are able to visualize cross-section plots in areas where we have both 1D models, which is described by cross-sections, and 2D domains, which are described by meshes. The two pictures shown in the slide show on the right side the cross-section extracted only from the 2D domain. We can see that the middle part is missing, where the river system is actually located, and the left side shows the full cross-section, which is automatically extracted in Mike Plus, which also shows the cross-section and the calculated water level across the entire cross-sections that we wanted to see. So by using Mike Plus in this approach, we can obtain an overview of the flow behavior, and we get it through both systems at the same time as a combined event. So coming towards the conclusion of to the end of the presentation, Mike Plus offers a complete set of tools, instruments, functionalities that can help you manage the entire water cycle, including urban networks, river systems and flooding, all under the same platform. And the main advantage is that it allows for seamless switching between different modules, different components, and it allows for adding necessary modules or functionalities as needed when the complexity of the study increases. Mike Plus can be used by a vast range of users, institutions, authorities, and so on. It can be used by water utilities, help them better understand hydraulic network performance, reduce non-revenue water, and also manage leaks. It can be used by city planners to prepare climate adaptation plans, to design resilient and sustainable urban solutions, protect the water infrastructure investments by looking at future-oriented types of investments. Regarding flood risk management, users can propose mitigation options for flood control measures and to build real-time flood forecasting systems. And for example, developers in urban areas can understand which areas are safe to develop on, which areas are maybe not, from a fluvial and also pluvial flood perspective. And also it can help them determine solutions to reduce the impact of heavy rains and also to mitigate the buildup of surface pollutants. And lastly, DHI also offers expertise and solutions in case there are no in-house modelers, so you can get in touch with us for any water-related issues. So thank you very much. This was my presentation. If you have any questions, I would be more than happy to answer.
I would rather now announce what else is upcoming. Just wanted to mention that on our Academy website, we have self-paced courses, which are very small, 1-2 hours. They are free. The blended courses are longer, also free for SMA clients. And the self-paced courses, some of them work even with the demo version, which is limited from the size, but you can still explore the Mike Plus interface as opposed to any other thing or as opposed to previous DHI products. So that's I quickly wanted to share with you. And apart from that, upcoming events, I mean, we are here in the webinar section. So the next Mike Plus webinars in autumn, always the second Wednesday each month, is on the 11th of October, learning how to work with the import and export tool, which is very powerful, goes way beyond just importing Mike Flood. You can import a lot of external formats. In November, we talk about building 2D meshes faster with an online tool because we have Mesh Builder, and this is a bit of a parallel development where we use online data and various tricks which are beyond our desktop products. Just join us to see it. And in December, getting the most out of hydrological models, I want to give an overview about the many models we have, because it could look a bit intimidating if you have no experience. Then in October, there is a full-blown online course, so 4 sessions, 2 hours each, about real-time control structures for structures and pumps in collection systems. So this is not so much about rivers, but about collection systems. I also want to mention that we have a Mike Plus playlist on YouTube, which is continuously growing. I mean, 10 videos so far, but we add one or the other each month. And the last one from Mathieu, who is the product owner of Mike Plus, is indeed interesting for you because it's about 2D cross-section plots. But as I told you, there are many others as well. And with that, I would like to conclude today's sessions. Thank you. And if you enjoyed this webinar, please spread the word. We very much rely on personal contacts and personal recommendations. For questions and suggestions, please contact Evan if it's about training and training in general. If you have support questions, please write to mike@dhigroup.com. That's our support center where our colleagues will answer your questions quickly. If you have something about this webinar in specific, then feel free to contact Mihai directly, but only if it's really about this webinar. Okay, I think that's it. And I hope you enjoyed it. Have a nice remaining day wherever you are. Goodbye.
Thank you all. Goodbye.